Hello everyone. So in this video I'll proceed with speed. Earlier we have done up to distance and displacement. So in this video we'll try to cover up from speed portion. So let us see what is speed. So what is speed? Speed can be defined as, or generally if we have got the formula of speed. So what is the speed formula? Speed is equal to distance by time. So you can write the definition of speed from this formula itself. How? Speed is nothing but distance per unit time. The distance covered per unit time is called speed. This is one definition. Second definition also you can write. If below time is given, then always you can use a phrase. What is that? The rate of change of. So how you define in terms of that? The rate of change of distance is called speed. The rate of change of distance is called speed. Okay. So I hope you have understood these two definition of speed. So speed equal to distance by time, and speed is a scalar quantity. Speed is a scalar quantity. Why it is a scalar quantity? Because you can see here it is a distance given here. Since distance is a scalar quantity, speed will also be a scalar quantity. The SI unit of speed will be what? The SI unit will be distance is meter and time is second. So it will be meter per second. And dimensional formula of speed is dimensional formula. What will be dimensional formula? You can see mass is not there, so m to the power 0. Distance is there, so L will be there, and below time, so time will go above, it will become t to the power minus 1. So this is the dimensional formula of speed. Now let us see little bit about types of speed. So basically here we are going to study about four type of speed. So number one is uniform speed. What is the meaning of uniform speed? You see, suppose from point A to point B, a body is going. So in the first second, if it covers 10 meter, second 20 meter, third second total distance is 30 meter. You see how much distance is increasing. It is increasing by 10 meter in every second. So speed, we can say here is nothing but uniform. Means distance is not increasing irregularly after certain interval of time. So after every second the distance traveled by the body will remain constant. That is why this kind of speed is called nothing but uniform speed. So how will you define uniform speed? When a body covers equal distance in equal interval of time. So when a body covers equal distance in equal interval of time, then we can say that this type of speed is nothing but uniform speed. Now second type of speed we are going to see is that non-uniform speed. Let us see a little bit this one. What is non-uniform speed? Again you can consider 2 point, and in the first second you can say the distance is 10, second distance is 20, but in the third second distance become 25. So you see between time 0 to 1, how much distance covered? 10 meter. Between 1 to 2, 10 meter, and between 2 to 3, how much distance it is? 15 meter. So the after every second the distance is not constant. Here it is 10, but here it become 15. If it becomes 15, then this type of speed is called nothing but non-uniform speed. Now how will you define? You can define like this. When a body covers unequal distance, unequal distance in equal interval of time, then we can say nothing but it is a non-uniform speed. When a body covers unequal distance in equal interval of time, remember this, in equal interval of time is called nothing but non-uniform speed. Okay. Now, basically, I already told you that we are going to study about four type of speeds. So we have already studied two type of speed. One is uniform, second one is non-uniform, non-uniform and non-uniform. The third one is very important that we should know. Third one is nothing but average speed. Average speed. Average. So average speed basically AVE, average speed formula is total distance by total distance by total time taken. Total time taken. Always remember this, average speed, total distance by total time taken. Now consider a Cartesian plane. This is the x-axis and this is the y-axis. So suppose a body moves from point A to point B. Point A to point B. So suppose the coordinate of this point is x1, y1, and similarly here it will be x2, y2. If it is x1, y1, then on the what is the projection of this point on the x-axis, it will be x1, and similarly projection of this point on the y-axis will be y1. And on the other hand, for B, it is the projection is x2, and for this point B on the y-axis, projection will be y2. So, but where from the body moves from which point to which point? It moves from point A to point B. So you can see that from point A to B, how much distance is covered along x-axis? It is nothing but x2 minus x1. This distance we have covered on the x-axis from point A to B, and similarly from point A to B along y-axis it will be y2 minus y1. Or if you consider this one to be time, then this will be t1 and this will be t2. Similarly here will be t1 and this will also be t2. Now average speed formula is what? Average speed average speed AV. This S means we have taken here speed and AV means average. So what will be average speed? Average speed formula is nothing but total distance by total time taken. So how much total distance is covered? Total distance covered is x2 minus x1. How much time is taken? That is t2 minus t1. So basically what is x2 minus x1? x2 minus x1 is nothing but the change in distance. Change in distance, and t2 minus t1 is nothing but the change in time from point A to point B. That basically what we can say here, 2 points are involved. If 2 points are involved, then this x2 minus x1 can also be written as delta x. Delta means delta represents change, and t2 minus t1 will be delta t. T2 minus t1 will be delta t. Again I am repeating, this delta represent nothing but change between how many points? Change between 2 points. So basically this is the average speed, okay, between 2 points. Now one special case is there, when initial velocity, when u and v are known, when u and v are known, then in that case average speed will be given by u plus v by 2. This should also, you should keep it in your mind. If average initial velocity, initial speed or final speed is given, then the average speed can be calculated by using the formula, very simple, u plus v divided by 2. So I hope you have understood this. This is the third type of speed. That is called average speed. So basically two formulas are there. One is total distance by total time taken, and second one is initial velocity plus final velocity, or initial speed plus final speed divided by 2. That will give you average speed. Okay. Now let us go to Another type of speed, last type of speed, that is called instantaneous speed. Instantaneous speed. Instantaneous speed. Very important. This is now what is instantaneous speed? Let us see a little bit. Instantaneous speed. So instantaneous means what? When we say instantaneous, that means at a particular point. That means at a particular point. When we say instantaneous, that means at a particular point we want to find the speed. So at one point, how much distance is changing in the given time interval, in the given time, that is called nothing but the instantaneous speed. So instantaneous speed, instantaneous instantaneous speed. Now you see, when you you can calculate this instantaneous speed from the formula of average speed. So what is average speed here? Average speed is delta x by delta t. So what is the meaning of delta x? Delta x is x2 minus x1 and delta t is t2 minus t1 as we have calculated. But we want to calculate instantaneous speed. So what is the meaning of instantaneous speed? Speed at a particular point. Speed at a particular point. Now, if you want to find, suppose speed here. At this point, if you want to, this is the point P, here I want to find the speed. So what speed should I calculate? I should calculate, obviously I should calculate instantaneous speed. Now, at this point if I want to calculate, then this point A must approach toward this and this point B must approach toward this, and at last it should meet at this point. Then only we will be able to calculate. Because if you want, on the other hand, how can I say, at the point P, what is the value of x1 and what is the value of x2? Both will be same. And what can you say about the value of t1 and t2? Also at the point P, t1 will approach here and t2 will approach here. To calculate speed at a particular point, P, this B also must be lying here and this A must also be lying here. Then only the speed will become a speed we can calculate at one point. But when we calculate here between A and B, this will be between 2 points, and that will be regarded as average speed. But our intention is very clear. We want to calculate speed at a particular point. At the point P. So at the point P, the value of T1 and T2 will remain same. If the value of T1 and T2 will remain same, that means what? This T2 minus T1 must be equal to 0. So if T2 limit delta T goes to 0, so we have given a limit that delta T goes to 0. So delta T value is what? Delta T means T2 minus T1. So T2 minus T1 must be equal to 0 only when? What is the condition for that? The condition is that T2 must be equal to T1. Delta T goes to 0 means what? T2 must be equal to T1. So if T2 is equal to T1, that means at how many points we are calculating? Exactly at one point. That is why this is called instantaneous speed. So instantaneous speed as INT. So if limit is there, limit delta T goes to 0 and delta X or delta T, this type of stuffs you will find, then you can directly convert into dx by dt, and this is called derivative of x. This is called derivative of x with respect to time. Derivative of x with respect to time. Okay, derivative of x with respect to time. So if x is given to you, you differentiate with respect to time. You will get nothing but instantaneous speed at a particular point, and point will also be given. So when you solve numerical problem, obviously we will get this kind of stuff. Okay, I hope it is clear. Now similarly, now what we are going to study? We are going to study about velocity. So velocity. So there is no major difference between velocity. There is no major difference between the speed and the velocity. Only difference is that when we talk about the speed, the body may move in a straight line or may not move in a straight line. But when we talk about velocity, the body always moves on a straight line. Body always moves on a straight line. Now, how will you define velocity? Velocity is equal to nothing but displacement per unit time. Displacement per unit time. Displacement per unit time. So what is displacement? Okay. Displacement means the shortest distance already we have studied. So since displacement is a vector quantity, or sorry, how can you define velocity? The displacement per unit time is called velocity. Displacement per unit time is called velocity. Also, we can say the rate of change of displacement. The rate of change of displacement is called velocity, as all earlier I have defined. Now, let us see little basics about that. What kind of quantity it is? It is a vector quantity. Why it is a vector quantity? Because displacement is a vector quantity. So displacement is a vector, so velocity will also be a vector quantity. What will be the SI unit? SI unit will be meter per second, because speed and velocity is almost same. Dimensional formula will also be same, because formula also same. You see, distance and displacement is almost same. The formula also remains same. That is why this parameters will also not change from there. Okay. Now let us see about different types of speed, different types of velocity. Again, number one, what is there? Uniform velocity. Uniform velocity. So what is uniform velocity? When a body covers equal displacement in equal interval of time, then we can say that it is nothing but the uniform velocity. On the other hand, what is non-uniform velocity? What is non-uniform velocity? Non-uniform velocity is nothing but when a body covers unequal displacement in equal interval of time, then we can say that nothing but non-uniform velocity. So non-uniform velocity also done. Non-uniform velocity, same type. Here the body moves in a straight line, but in the previous case, in the speed case, the body does not move in a straight line. Uniform, non-uniform velocity. Third one, what is there? Average velocity. Average velocity. So what is average velocity? Again, total displacement by total time taken. So if you calculate average velocity, that formula will be equal to nothing but v2 minus v1, v2 minus v1 divided by t2 minus, sorry, x2 minus x1. Vector will be there because these are the vector quantity. This, when arrow is there on the head, then it is the parameter regarded as vector. Suppose I put a arrow on your straight line. I mark a straight line on your, sorry, arrow on your head. That means you are a vector. Why? Because you will move always in a straight line. So this arrow marks that this displacement is a vector. Means this should be moving in a straight line. This quantity deals with the straight line. Okay. So if you take this one, already we have done delta x vector by delta t. This is the average velocity. So fourthly, what was there? Instantaneous velocity. Instantaneous velocity, what was there? Instantaneous velocity, what was there? V I N S T will be equal to dx vector divided by dt. Dx vector divided by dt. As already I have done this one in case of speed, so I hope you have understood this. Okay. I hope this one is clear to you all. Now, acceleration is also of same type. Acceleration, let us see a little bit about acceleration also. So, acceleration means what? What is the meaning of acceleration? Change in velocity per unit time. Change in velocity per unit time. Change in velocity per unit time is called acceleration, equal to change in velocity. Change in velocity by, also we can write, time taken. Change in velocity by time taken. So basically formula is a equal to v minus u by t. Already you have got this. So what kind of quantity is velocity is there? It will be a vector quantity. Secondly, what is the SI unit? SI unit is meter per second square. Why? Because velocity is meter per second and here time is there. The time will be second, so meter by second square. So this is a meter by second square. Meter per second square for acceleration unit. And dimensional formula is there. you can see mass not there, length is there, velocity is there. The velocity is already what, lt minus 1. Velocity is already lt minus 1. Okay, this velocity dimensional formula is lt minus 1, but t will go from down, it will go above, it will become minus 1, so lt minus 2. The dimensional formula will be lt minus 2. So again you see the same type of four type of acceleration will be there. Same four type of acceleration will be there: uniform, non-uniform, uniform, non-uniform, average acceleration, and instantaneous acceleration. So let us see little bit all of them. So basically, see, I think acceleration you should understand a little bit more nicely. So suppose a body is falling here, body is falling, really falling. So here the velocity was 0. Suppose after 1 second the velocity become 10. After 1 second velocity will become 10. Now after 2 second velocity will become 20. Then how much velocity is increased? It is increased by 10. After 3 second velocity become 30. After 4 second velocity become 40. If it happens that this kind of velocity is called uniform velocity. So that uniform sorry, not uniform velocity, it is called uniform acceleration. It is called uniform acceleration. Now if after third second, suppose in third second the velocity becomes 35. So here velocity increase is 10, here 10, but here how much it is increased? It is increased by 15. So what we can say here? We can say that this acceleration is non-uniform. Acceleration is non-uniform. So whatever equation of motion we studied or will study or we studied in class 9, all will be uniformly accelerated motion. All will be uniformly accelerated motion. Where the acceleration remains same, that is called uniformly accelerated motion. Uniformly accelerated motion. Okay. Now, uniform, non-uniform, already you understood what is non-uniform acceleration and uniform acceleration. Average acceleration will be equal to what? Again, the same thing will be there. Average acceleration. A average acceleration will be equal to what? V2 vector minus V1 vector by T2 minus T1, already you know. This will be delta V vector by delta. This is the average acceleration. And instantaneous acceleration, what will be instantaneous acceleration? Limit you have to put. So what that limit is, delta t goes to 0, then only it will lie on a single point. So this will be delta V vector by delta t. So if you convert this one, then it will become dv vector by dt. So when velocity is given to you, you just convert into you just differentiate with respect to time, you will get nothing but the acceleration. Now let us go to some numerical problem. Now let us go to some numerical problem and see how it can be solved. So I'll just dictate the question. You can note down the question and I'll try to solve. On a 60-meter track, a train covers the first 30 km with a uniform speed of 30 km per hour. How fast must the train travel the next 30 km so as to average 40 km per hour for the entire trip? Now let me explain this one little bit by means of little bit diagram. Okay, by means of a diagram so that you can understand better. Now the question is there, the solution will do. So on a 60-meter track, a track is there A, B, and what is the length of this track? It is nothing but 60 km. So at the point P, this will be 30 km per hour. This is 30 km, and this will also be 30 km in the middle. Okay. Now, first of all, we have to write what are the things given here. So what things are given here? What parameters are given? Distance d1 and this distance d2 is also given. So d1 and d2 both are equal to how much? 30 km. Both are 30 km, and that we have considered d for simplicity. In the first point from A to P, what was the speed? The speed was nothing but 30 km per hour. 30 km per hour. But from P to B, how much speed was there? That we don't know. So our intention will be to calculate that speed. So as the average speed, total average speed is given here is nothing but S2 we don't know, that we want to calculate, and S average for the entire journey is nothing but how much it is given. It is given 40 kilometer per hour. Now what we want to calculate here, we want to calculate average speed, and average speed value is given in one parameter which will be unknown, that we want to calculate. So average speed formula is what? Total distance by total time taken. That means obviously we have to calculate this total distance and total time taken. So what will be total distance? Total distance will be equal to d1 plus d2 must be equal to d plus d, and that is nothing but twice d. You can check. Total time taken. Total time taken. So total time taken will be equal to what? It will be equal to t1 plus t2. T1 means from A to P and T2 means from P to B. So what is the value of T1? T1 will be equal to distance by speed. Time equal to distance by speed. So what is the distance? Distance is T and speed over there is D by S1, and here similarly D by S2. D by S2. D by S2 is there. Now if we calculate this, if we take D common, then what is the remainder inside? A remainder will be S1 plus S2 divided by S1 S2 if we take the LCM. Okay. Now average speed, what is the formula? S average equal to total distance by total time. What is the total distance over here? Total distance is nothing but twice d, and total time taken is nothing but d S1 plus S2 divided by S1 S2, and average speed is given nothing but 40 km per hour. So you can see this d and d will get cancelled. This d and d will get cancelled, and if you S1 and S2 will go above, this 40 will be there, S1 S2 will be above, and this what is the remainder? 2 S1 S2 will be there, and S1 plus S2 will be below. If we put the values here, what is the value of S1? We have average velocity speed we have put, and S1 value also if you put here, if I put over here, 2 S1 is nothing but 30 into S2 divided by 30 plus S2. 30 plus S2. So if you solve this, the value of S2 you will get is nothing but 60 km per hour. I hope you will be able to solve this equation. So if you solve this, you will get the value of S2 to be 60 km per hour. So very simple about the average speed one problem we have done. Now let us see one another question regarding this average speed only. Okay. You can see another question, you can just note it down, and I will just dictate. The position of an object moving along x-axis is given by x equal to a plus bt square. X equal to a plus bt square. Where a equal to 8.5 meter and b equal to, you see meter is given, so that means it indicates distance or displacement. B equal to 2.5 meter per second square. That means what? It may be acceleration. And t is measured in seconds. What is the velocity at t equal to 0 second and t equal to 2 second? What is the average velocity between t equal to 2 second and t equal to 4 second? So always remember, when we want to calculate instantaneous speed, that means we have to differentiate the given displacement. Okay, so let us see. If I solve it, then only we will understand better. So a equal to how much given? A equal to how much it is given? 8.5 and meter, and b equal to 2.5 meter per second square. This is given parameter. Now x equal to how much it is given? A plus bt square. So our intention is what? To calculate the instantaneous speed. So how to calculate instantaneous speed? Dx by dt. Instantaneous speed can be calculated by differentiating by differentiating instantaneous speed or instantaneous velocity, same thing only here, because it will depend only on direction. So v will be equal to dx by dt, and what is the value of dx? What is the value of dx? X is nothing but a plus bt square. Differentiation is there, you just little bit go through the differentiation, okay now. So d by dt of a, separate it, plus d by dt of bt square will be there. So since a is a constant, this will be 0 and b is taken outside. If we differentiate t square with respect to time, it will be twice bt, that is equal to twice bt only. This is velocity. This is velocity of the object. Now, our intention is to calculate average instantaneous speed. So at what time? At time equal to 0 second and time equal to 2 second. So velocity at uh, okay, velocity at t equal to 0. At t equal to 0 second. Velocity at t equal to 0 second will be equal to what? This is the velocity. So velocity at time 0 second will be equal to 2 into b is nothing but 2.5, and this will be 0. This will be nothing but velocity. So when time equal to 0, velocity also equal to 0. Secondly, velocity at time t equal to 2 second. So when time t equal to 2 second, what will be the velocity? 2, value of b is nothing but 2.5, and time is nothing but 2. So 2 into 2 4, 4 into 2.5 will be nothing but 10 meter per second. 10 meter per second. So this is all about instantaneous velocity. But another, in the second part of the question I already dictated, it is asked to calculate average speed between t equal to 2 second and t equal to 4 second. T equal to 2 second and t equal to 4 second. T equal to 2 second and t equal to 4 second. Now let us see. Second part of the question, what is their average velocity? So V average will be equal to what? X2 minus X1 divided by T2 minus T1. Already I said. So what is the value of X1 between t equal to 2 second and t equal to 4 second? So when I put here t equal to 2 second, t equal to 4 second here. So in the rough you can just go through. When t equal to 4 second, what will be x? X will be equal to a plus b. 4 will be 4 square. 4 square will be 16. So what will be here? A plus 16b. And similarly here what will be there? A plus 4b divided by time equal to 4 minus 2, because t2 is given 4 and t1 is 2. So this one we have calculated by putting the value of t2 and t1 over here. We have got the two displacements. So this will, if you break, minus a will get cancelled and minus 4 will be there. So it will be 12b divided by 2, cancel 6 times. Now V average will be equal to 6 into 2.5, that is nothing but 15 meter per second. So this is the average velocity. This is the average velocity between 2 points. I hope you have understood this, and I'll dictate some questions. Okay, I'll dictate some questions, and I think we will be able to do this. So you see, one thing I missed here: instantaneous acceleration. Instantaneous acceleration equal to a equal to dv by dt, but d by dt of velocity equal to what? dx by dt. So it will become second order differentiation of displacement. So acceleration can be defined as second order differentiation of displacement. Acceleration can be defined as second order differentiation of displacement. Okay, so I'll dictate some question. You will try to solve by yourself. Okay. The displacement of a particle along the x-axis is given by x equal to 18t plus 5t square. Calculate problem number 1. Instantaneous velocity at t equal to 2 second. Average velocity between t equal to 2 second and t equal to 3 second. And number 3. Instantaneous acceleration. So in this video only this much, and in the next video remaining portion I'll do this equations of motion by calculus method and by graphical method, and graphs we have not seen till now. Intentionally I have not done, because this graph in this chapter is really very important. Together I will do it last, okay, in graphical analysis of the things. So if you like the video, please like, share and subscribe. Thank you very much. We'll come in the next video with the remaining things. Till that, goodbye.